So we'll look at section 6A, which is titled Characterizing Data, and more specifically we'll look at measures of the center. Basically that's just a fancy way of, measures of central tendency is a fancy way of saying that we're going to talk about things that you have discussed before, I'm sure: mean, median, and mode. You'll find that in this particular section, and basically for this unit, from this section onward in this unit, we're going to get a lot more computational. So those graphs were just, a lot of just reading the graphs and interpreting and that sort of thing. Yeah, a little bit of computation, but not too much. From here on out, there's a lot more computation. You'll notice that you do have a formula sheet for this unit as well. So I'll try to remind you that when the formula is on the formula sheet, but you have that in Blackboard to reference. So you'll know what you see in Blackboard is what you get when you take the test. Alright, so we'll start here with mean. That's just a standard average. It's another word for average is mean. In statistics, they will oftentimes refer to it as X with a line on the top of it, and that's read as X bar. And that's just simply, your classic average. Add up all your data points and divide by the number of data points that you have. A fancier notation, though, is that this little sigma, Greek letter here, sigma, and that sigma in mathematics means the summation of all of your x's divided by n, the number of all your data points. Okay. The mean takes into account all of your scores and is affected by extreme scores, which are outliers. We'll be talking about outliers in just a few moments. But it is probably the most common, most widely used measure of central tendency. So here in example 1, this represents the ages of people that were at a child's birthday party. So you can see 3-year-olds, 6, 7, 8-year-olds, on up to those in their 50s and 70s. We want to calculate the mean age at the party, the average age of the party. So, formula, as I stated before, is to add up all your x's and divide by the number of data points. So here, if you take the time to add up all of these ages that are at the party, you should find that that adds up to 350, divided by the total number of people at the party. And so if you count that, you should find that there are 18 people that were at the party. And then after you do 350 divided by 18, you'll get 19. So we can say 19 is the average or mean average age at the party. But the problem with that is that it has been affected by, you can see the majority of the people at the party were ages 6 through 8. But what's happening here is that these larger numbers, those in their 50s and 70s, these few little outliers here, are greatly affecting the average. Okay, so that's where sometimes the median can be more beneficial. The median is the value in the middle of a set of data points that's arranged from smallest to largest. So it's really important that you note that you always need, anytime you're trying to find the median, you have to put your data in order first. In our class, median is always denoted by capital letter M. And what should be nice, and I'll point this out to you when we find the median in just a few moments, once you find the median, you should either be able to circle it within your data or you'll insert it. I'll talk a little bit more about that in a moment. But once you've done that, either inserted it or circled your median, you should find then that you have the same number of data points above as well as below, or to the left as well as to the right of that particular median. There's a formula to find the median. Median is just n plus 1 divided by 2. N just stands for the number of data points that you have. I'll give you an example. Suppose you had 7 data points. Then for my n, I'd put in 7. 7 plus 1 divided by 2. Obviously, 7 plus 1 up there is 8. 8 divided by 2 is 4. So what that means then is the fourth entry. This is giving me the location now. The location of my median is going to be the fourth entry in my list. And then I'd go in and I'd circle the fourth number in my list. And then what I should find then is I have 3 data points below me and 3 data points above that median. Say for example there were 8 data points. Again, to find out where my median is, for n I put in my 8 plus 1 divided by 2. Obviously that's 9 over 2 gives you 4.5. So what that tells us then is that the median's halfway between the 4th and the 5th entries. So what I'm going to end up having to do now is just do a small average between the 4th and 5th entries. So I'm going to take the 4th number in my list plus the 5th, add it together, and divide by 2. That number then is going to lie between those, and that would be an example of a median that would need to be inserted between the fourth and fifth numbers, okay? Um, but the nice thing, like I mentioned a minute ago, is that the median is not affected by any outliers, okay, which can be an advantage. So if we look at that same birthday age group again, and you notice here my data is already in numerical order, so I don't have to do that first. I just need to find out, what is the median. So I'm going to figure out, okay, well, where is it? Using my formula, it's the number of data points, so there are 18 people at the party, add 1, and divide by 2. Obviously, that gives you 19 over 2. Divide 19 divided by 2, and you get 9.5. So what that tells me then is that my median lies between the 10th, between the 9th and 11th, between the 9th and 10th numbers in my list. So I count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 9th and 10th number in my list. I'm going to box those in there. Those are the 9th and 10th numbers in my list, so I'm going to write this out, that I would take the 9th plus the 10th and divide by 2. So the 9th number in my list is 7, plus the 10th is another 7, and divide by 2. You might already surmise, well, hey, you're just going to get 7, but I'll show my work here. You wouldn't always get the same number. So 14 divided by 2 obviously then is 7. This is a 7, though, that needs to be inserted. So I would take that 7 and I would insert it right there. What happens then is I should have the same number of data points to the left as well as to the right. And so if you look over on the left-hand side of this 7, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. And on the right-hand side, 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. If you take the time to either insert it or to actually box in your median, that technique that I just showed you about the median falling halfway in between, that'll be a nice way to check yourself. Make sure that you're not lopsided. You don't have 3 entries on one side and 5 on the other. You want to be directly in the middle, okay? Question below then says, well, which measure of the center, the mean or the median, best describes the typical age at this party? I hope you would agree that, as you can see, the majority of people at the party were between 6 and 8. The median is a better representation because it's not being affected by these extreme outliers. Okay. Example 3 wants the median gas price. First thing I need to do, just sort of glancing here at these numbers, they are not in order. Very first thing I need to do then is put them in order. I always recommend that if you have to do that, put it underneath the numbers, because sometimes I'll find folks that they forget to, they won't include all the data points when they rewrite them. So if you put them underneath each other, you'll be less apt to forget them, or, to miss a data point. So I've got my 2 319s, then I'll do my 347. That one, 353. 354, 357, and then 369. Okay, now from here, I'll use my formula again. Number of data points, 1, 2, 3, 7 data points, so I do 7, always add 1 and divide by 2. Of course, that's 8 over 2, which is 4. When it comes out to be a nice whole number, then what that's telling you then is the 4th entry is my median. So I just count from the left, 1, 2, 3, 4. Boxing it in. 353 then is my median, and you can notice on the left hand side you have 3 data points below that. On the right hand side you have 3 data points above that, so you're balanced. And so $3.53 is the median gas price. Okay, flip on over to the next page. I'll let you try example 4 and number 5. I'll scoot on down to mode. Mode is the score that occurs most frequently. So it'll be, I just think mode most. The definition for mode is not on your formula sheet, so it is one that you need to memorize, but mode, think most. When 2 points occur with the same frequency, same greatest frequency, each one is a mode, and the set is referred to be bimodal. Bi meaning two, so having more than one mode. When two or more scores occur at the same greatest frequency, each is a mode, and the set is to be multimodal. Okay. When you don't have a score repeating itself, we say that there is no mode. Don't fall into the trap of saying, oh, well, if nothing repeats itself, then the mode is zero. You can't say the mode is zero, because the mode, then you're saying that zero exists as part of your data set. So you need to write actually no mode. Okay. The mode is also not affected by your extreme outliers either. Sometimes frequency tables can help you to find the mode. Some good examples that I put here in your notes, as far as, when might we use mode, because mode's really easy to find, but where would we use it? Say for example, you're in charge of buying merchandise at a particular store, and like say men's shirt sizes, for example, and you recognize that extra large, and extra large sell more frequently than smalls and mediums. So you, as the merchandise manager, would say, okay, let me be sure that I order more of those so that they sell and less of the other. Likewise, a home builder is going to be interested in what size home is selling most often, so that he builds homes that are appropriately sized for the area, so that because he wants them to sell, obviously. I'll do example 6, and I think that hit the mode very easily. In example 6, it wants to know what's the mode age at the party. So that's the one that occurs most often, and you can, in this case, since all lined up, you can see that 7 occurs most often, so we'd say 7 is the mode. Age 7, I should say, is the mode. Okay. I'll let you try example 7. Scoot on down to example 8. It says a subdivision has houses that are priced as follows, so you can see those house prices. In part A, it wants the mean price for the houses, so mean average price of the houses. So remember, that just means add up all those house prices and divide by the number of data points. So if I add up all those house prices, you should find that to be 1,488,000. Divide by the number of houses that we're looking at there, and you should find that to be 8. After you do that division, average house price you would find to be $186,000. Part B then wants, okay, what's the median of this data? Alright, so remember, going back and looking at your data, hopefully you recognize the very first thing I need to do to that data, put it in order. It is not in order. So we'll do a little bit of abbreviation here. 160K for 160,000, 170, 175, 179, 184, 188, and 250. I want to figure out, okay, where is my median? There are 8 data points, so 8 plus 1 divided by 2. 9 divided by 2 gives me 4.5. So what that tells me then is that my median lies between the 4th and 5th entry. So I'm going to take the 4th plus the 5th and divide by 2. So the 4th and 5th numbers in my list are 179,000 plus 182,000. Divide that by 2. You should get a final answer of 180,500. That would be the median home price. And you can notice, if I go back in and if I were to insert that 180,500, it would fall right here. And you can see then that I have 4 home prices below that and 4 home prices above that. In example 9, what do you think would the mean or the median change? Would the mean or the median change if the $250,000 house actually cost $2 million? And hopefully you would recognize, well, only the mean is going to change, because if I take that $250,000 home and I just make that 2 million right there, that is not going to affect the fourth and fifth entries for my median. But it is going to add, instead of 250,000 into this number, it's going to be adding 2 million into that number. So the mean is the only thing that's going to be affected there. And which do you think gives a better description of the prices of the homes? Likely the median in this case, again, because there are, even 250,000 could be considered an outlier, but especially if you bump that up to 2 million, 2 million is a strong outlier. Formal definition of an outlier: a value in the data set that is much higher or much lower than all the other data values. In this example here down below, I said identify and circle the outlier in the home price data set. As we, as I just sort of alluded to, that 2 million obviously then is my outlier. But we would say that is an outlier to the right of the data, because it's on that far right side. All right, we'll flip it over to the last page. Sort of fill in some pieces here. The mean is strongly influenced by a few large or low data points. An outlier pulls the mean toward that particular direction. Thus, the mean should only be used as the only measure describing the center of the data if the data set is relatively consistent and does not contain outliers. So essentially, we're just saying, since the mean is so drastically affected by outliers, we should only use the mean whenever we know that our data is very consistent and it doesn't have any outliers. And we don't, at that point then, we don't want our data to be skewed. We don't want, and we'll talk about skewed here in just a moment. Usually you're going to ask yourself, is mean or median a better typical value? And there can be a little bit of a gray area on that. The mean and the median coincide for symmetric distributions. And just below here, you can see a nice graphic. This graphic here on the far left is an example of a symmetric distribution. The mean and the median are exactly the same. But if the distribution is, symmetric, if the distribution is symmetric, we can use either the mean or the median to give the center. Since we're more familiar with the mean, we probably would just usually use that by default. The mean and median do not coincide for skewed distributions. In a skewed distribution, the mean is drawn toward the tail of that distribution. So in this case, the median is the better choice because it's being obviously drawn to one side or another. Some examples. Symmetric. Price of 20-pound dog food, 20-pound bags of 20 different brands of dog food. Most likely there's going to be very little variation in the prices because manufacturers want to sell their product, and if they're not competitive, then they're not going to be selling that product. So the mean and the median price is probably going to be right up very similar. All right, an example of left skewed, and to tell the difference between being left skewed versus right skewed, it's always where the tail is. So here the tail is on the left, over here the tail is on the right. So wherever that tail is, that tells you how you're skewed. So don't look at it as it's more concentrated on the right. No, since it's tailing off to the left, it's left skewed. Tailing off to the right, it's right skewed. An example here for left skewed is, you probably have seen this on the road before. You've been driving along, all of a sudden somebody spots a cop, and then there are some people that just slow way, way down, and, kind of unnecessarily, and then those that are, right where they should be, and then there's still a few that are saying, I don't care, I'm just going to keep on trucking it, at the speed I was. So that would be an example of being left skewed. Right skew would be an example, ages of people who visit an amusement park. You'd have that average age, and then those that are much older than that average age, there's going to be fewer and fewer of those people. Okay. Um, gave you some examples down here below. I'll let you read this at your leisure. I think you can finish up the notes with what I have online for this section.